Alright, so right now we're just going to be talking about the difference between molecules, compounds, and free elements, and a pure substance as well. So first let's talk about just water. So we know that water is H2O, right? So first, we're just going to deal with the first question is water a pure substance? So a pure substance, you have to have consistent composition, meaning that the composition of the glass of water is only water. If you go out to anything like oceans where we have salt water, that obviously has salt in it, so that's not a pure substance right there of water. If you have rain that's coming down, there's impurities in it like dirt or minerals. Even the water that we drink, the reason why it tastes good to us is because of the minerals and things that are in the water. So if we are picking up water that's around us, that's actually not a pure substance. Though we take the water that we take around us and we boil it, when we boil it, the steam that arises from the boiling is actually the pure substance of water. It's a pure substance of water as it comes up. So H2O can be a pure substance and it cannot. Distilled water is one thing that is very, very close to a pure substance. I believe it's like 98% pure substance. So they have a little bit of impurities in there, but for the most part it is completely composed of just H2O. So now, is water a compound or is it a free element? If we look at it, H2O, so we have different types of elements put together. So it's not a free element, so we know that, but is it a compound? For something to be a compound, it needs to be able to be broken down into its separate elements by chemical processes. When you can take an electrical current and put it through a tub of water. So if you have a tub of water here, and you put electrical currents through it, it can separate out into just hydrogen and oxygen. So H2O would also be a compound. Now we're going to take different elements. So this is part of the second question. To determine what each of the following are, so we've got chlorine gas, hydrogen, water again, sodium chloride, bromine, and oxygen gas. So if we look at, let's just first talk about chlorine gas. So we want to know what chlorine gas is. Chlorine gas, so we know that it's not a free element because we already have two things put together, so it's not a free element. So then is it a compound or is it a molecule? In a compound, you have to have two different substances. So where we have two things of chlorine, that does not count as being a compound. So chlorine gas is actually a molecule because we have two chlorines held together by covalent bonds, but they are the same element, so it does not count as a compound. Plain hydrogen by itself would be considered a free element because it is just hydrogen by itself, only one, so it's a free element. H2O, as we talked about, is a compound. It is also a molecule, though, because you have the oxygens and hydrogens that are held together by covalent bonds. So a molecule can be either two or more elements that are the same or different. So water is actually a compound and a molecule. Next we have sodium chloride, or regular table salt. This one is actually a molecule. It can be broken down into different parts, obviously, but the process is a little bit different. So it's mostly considered just a molecule. We have bromine next. Bromine is like our hydrogen in just that it's just a regular element, so it is a free element. And last we have oxygen gas, which is very similar to our chlorine gas in that it is a molecule because it has two elements in there, but they are the same kind. So it can't be considered a compound because they are the same. So it is considered to be a molecule.